We are at top of the hour, so we're going to go ahead and get started here today.
Yeah.
So let me share my screen because I always miss my intro slides. We have with us today my friend Brady Pitcher, who is a great water manager and a member of the Sprinkler Supply Water Management Division. So Brady is a good friend of mine and somebody who I've done live training with more than I would say anybody else. So
the Brady and Ben show.
The Brady and Ben show is well rehearsed, absolutely. And so excited to have Brady here, and we're gonna just delve into the subject of the day, which is adjusting your irrigation frequency in auto mode. Now, this is a departure or a continuation of a conversation we started a while back. On an earlier episode, we talked about adjusting your station runtime in auto mode. And during that conversation, there were a lot of questions about frequency that I kind of had to put a pin in, right? People asked about target mad, people asked about root depth. And those really don't adjust your runtime in a night, they adjust your frequency. So today we're going to just pick up where that conversation left off and just go down the road of how do I get more days out of my irrigation schedule when I am scheduling a station using the Automated by WeatherTrack feature. Before we do that, I'm going to jump in and interview Brady for a minute. Brady, I always start by asking the water managers, how many WeatherTracks do you have in your WeatherTrack account? Do you know?
Last time I logged in, I don't know the exact number, but it's somewhere around 1,500 controllers that I have on my account.
That's
which is quite a few.
That's a good number, Brady. That's a good number for sure. And give the audience a little bit about your background. Tell us how you got into this irrigation thing.
So I grew up on a dairy farm in northern Utah in a teeny little town called Cornish. And those of you from Utah are like, where in the world is Cornish? It's a teeny little town of maybe even now 250 people. I grew up milking cows and ironically grew up moving sprinkler pipe. So I grew up in irrigation. And as I was thinking about what I wanted to do, I found landscape architecture and actually got a degree in landscape architecture. Went to Utah State, also went to University of Nevada, Las Vegas, got a degree as a landscape architect and practiced as a landscape architect for about 8 years. And found that I really loved the application side of landscape architecture, about making it happen, and got into irrigation sales and found myself connecting with Sprinkler Supply Company, being part of their water management team. And ironically, I started my life out in irrigation and now continue in irrigation. And it's something that I've just have a passion for. I love it, and I love interacting with people and helping people is really what I love doing.
And you still milk cows every day, right?
Yes, of course.
Keep the cows and the irrigation. It's all good.
It's
all right. So with that, let's jump on into this. Let's talk about adjusting your stations in auto mode to create greater frequency, right? And this all starts with the WeatherTrack idea of depletion, right? We are going to talk today about calculated soil depletion that is a station by station calculated value for every station that you manage. And we talked about in the previous episodes how we have basic settings and advanced settings, and there's a lot of different factors that go into the depletion model. Brady, you want to talk about the glass of water example? Will you tell them the glass of water thing?
In fact, this is something that I talk with our customers and WeatherTrack users quite a bit. If you understand this concept right here, the depletion model, and really truly, if this sinks in, you'll understand how to use WeatherTrack more effectively. And the basic concept is WeatherTrack imagines kind of a glass of water under every zone. And that glass of water is some level of full. And this is what the depletion model essentially is. So for example, in the first day right there, day one, it rains right there and has filled up that glass a little bit. The next day it's sunny, day two, depletes that glass a little bit. And that line that we'll see, we'll talk about that in the next slide, that line right there. Once it hits that line, that depletion, that MAD line, management allowed depletion line, then it'll start to kick in and refill that glass, is what it is. So, and that's how WeatherTrack works within that boundary right there, 50% deplete to 0% deplete, glass full.
Right. So we're just watching that depletion for every station, and as that station gets thirstier and thirstier, we're monitoring that. Once it passes the maximum allowable depletion, we prompt irrigation and fill that glass of water back up.
Yep.
And we're going to use this analogy of the glass of water in this conversation a lot today. Yep. So that's why we're spending time setting it up. All right.
Head to the next one. So this right here really talks about that management allowed depletion. And within WeatherTrack, you can adjust that at that trigger point at which it's going to water. And how does that affect? I mean, we're talking today about frequency. We're talking about day frequency. Depending on where that level is, will determine the spread of distance between the days of watering. That's what it'll determine. Now, and you have all those options as far as, from 80 to 20. Now, however, what we would say though too, is that 50% is where we would recommend you be. Most of the time. It's very, very rare that you would be anywhere besides that. And again, that's at the point at which depletion happens, water leaves the soil in the plant, and once it passes that point, it'll start to fill that back up.
So as an example, if you adjust your target MAD up to 60%, you're saying don't let that glass of water deplete all the way to 50% before I irrigate. Just let that glass of water get to be 60% full and then prompt irrigation. So by a higher target MAD will prompt greater frequency in your irrigation schedule. Sorry, go ahead, Brady. I didn't mean to interrupt.
No, you're doing great. So that directly affects frequency. Yeah. If you want to understand how frequency happens, spread of days, target MAD is one way it does it. Now the next one, if you want to go to the next, unless you have something else, Ben, you want to mention here. Soil type is another one that will directly affect frequency. And this is a good example. I like the fact that Ben's showing this. If you haven't done this already, this is a good simple test if you can dig down a decent amount in your soil, grab a piece of soil in your hand, make sure it's a little bit wet. If not so, get it a little bit wet and just squeeze it a little bit. Squeeze it in your hand. And depending on the indention that your fingers make in that soil determines the soil type that you have. Now this is not a scientific way of doing it necessarily. It's not precise, but it's a good way of doing it on site. Another way that I've done this actually is I've done a similar thing with what's called the jar test. I don't know if you're probably a lot of people are familiar with that. You do the same thing, grab a soil sample, put it in a jar, fill that jar full of water, shake it up, and then let it sit. And you can actually see the separation of the different soils in there. And the finer sediment is on top and then the larger pieces. One way you can think about this is sand. Water travels through sand really easily. Imagine it kind of like boulders, just like this right here. Perfect. Thank you, Ben. So sand, infiltration rate on sand, water travels through sand very quickly, whereas clay, it holds that. And speaking of that holding it, that field capacity, so something like a clay soil has a much larger field capacity, holding capacity of that. And then it also has a bigger, to that bottom point right there, how long does the water stay in the soil? Sand, water does not stay in the soil in sand for very long, whereas with clay, it stays in there for a very long time, which then, frequency, again talking about frequency, you can push your days further out depending on your soil type. Okay. Anything you want to add there, Ben?
Yep. Nope, you're good. Keep going.
Okay. So this right here, a couple of good examples. I mean, I've briefly mentioned these. If you have a clay soil, if you put in there, for example, like it shows on the bottom right-hand side there, if you put in, you have clay soil, you're going to have shorter cycles, longer soaks, and that has a lot to do with the fact that you have more available water, which means you can go further in between your waterings. That's what can happen. So same thing, and then talking about that on the opposite side of that, sandy soil. You can have longer cycles, shorter soaks in order to make things healthy, but then you're going to probably, the days in between those are going to actually shrink up in order to meet the need of the soil specifically.
Right. So when we think about sandy soil, we know that water will infiltrate very quickly. So our maximum cycle time can be longer, right? We're not going to get runoff because that soil is sucking that water down. We don't need as long in between cycles. So because that same fact, right? So we can have longer cycle times, shorter soak times, and we'll get into that in an upcoming episode where we talk about that cycle and soak a little bit more in depth. Because the soil plays so many roles in how we irrigate, we had to touch on this irrigation frequency, right? That idea that clay soils will hold water a lot longer than sandy soils and be available in the water. So when it comes to irrigation frequency, it really spreads out the number of days that we can wait in between irrigation.
The important takeaway here should be that you don't adjust the soil type to try to manage a frequency event. Leave the soil type to be reflective of what's really the condition in the field, and know that the WeatherTrack science will handle that. There's other ways to manage frequency by shortening MAD, but clay is clay. You don't want to change that just because you want a different irrigation outcome. Leave it, let the science work.
Absolutely. So definitely this is one where make the information in the program match the information in the field. And if I could nudge you toward the middle three settings, even though we have a sandy and a clay setting, those represent extreme soil types. So extreme sand or extreme clay. So more than 95% of the stations that I look at will have the word loam in it, whether it's sandy loam or clay loam. It's one of those middle three settings.
And I'd say the same thing with, I would say high 90% of the stations that we help program here in Utah, we set as clay loam. It's very, very rare that we set anything besides clay loam.
All right. I got called out and I said something wrong on target MAD, so I have to go back. Before we move off of soil type, we're done with soil type, but I explained this incorrectly. At 60%, we're saying let the glass get to be 60% deplete instead of 50%. So it actually increases the amount of time in between irrigation, not less, right? The shallower the glass, if I say, let that glass get to be 40% before I reprompt irrigation, that will give you the greater frequency. So whoever gave me that note, sorry, I got caught up in it and I said it wrong, but definitely you are right on point. So again, to get more frequent irrigation, the lower the number, the more frequent the irrigation. Sorry, good call out. Don't want anybody to be confused.
So the next thing that we can talk about that deals specifically with frequency is plant type. Plant type really is just another way of saying we're assigning a crop coefficient to a station. And that's something I like about what WeatherTrack does, is it assigns it by station. So when you say, for example, that I have cool season turf in this zone, it's applying a crop coefficient, and that crop coefficient will then push out the frequency of how often something waters.
So when you tell WeatherTrack that you've got cool season turf, behind the scenes, WeatherTrack knows the science of how much water that type of plant pulls out of the soil. And so that's what crop coefficient is, right? Every different type of plant pulls a different amount of water out of the soil. So your shrubs pull a different amount of water than your grass does. And this can definitely affect the frequency that we need to irrigate.
Yep. Spot on.
Good enough? Anything else on plant type, Brady?
Nope.
So the one thing that I would say is this is something that's great for our conservation folks, right? If you do plant designs to limit the amount of water, make sure that you're scheduling them appropriately. The The xeric gardens are super happy and healthy on a lot less water. So we're going to select a plant type that needs that reflects that lower crop coefficient.
Hey, Brady, we get this question a lot from different folks who may not be plant pathologists, right? So generally, when would you pick high or medium or low water use shrub? I mean, give some botanical and common name examples of plants that might fall that are common in landscape.
That's a great question, and I lean on my knowledge as a landscape architect oftentimes. However, if there is a plant that I'm not familiar with, what I typically do is I tend to go middle of the road. So I'll put it as at medium is what I typically do. And something that I share with people too is that I've had a couple of people ask me the difference between shrub versus mix, which it's simple once you explain it, that shrubs are shrubs, obviously, but mix is a mixture of trees and shrubs is what it is. So that would be my answer.
So how would you water daylilies or society garlic? What would you pick for that plant type?
Daylilies versus what?
Society garlic, which are very common, or ceanothus, or, you know, these are just different plants that you see in common landscapes around commercial office buildings.
Yeah, I would probably put those in a medium water shrub is probably where I'd put those.
The way I think of it, Ben, is if I think of it as a tropical plant, I think of it as high water use, something that's just going to burn through the water. Most of what I see in commercial landscapes and residential landscapes falls in that medium water use category. And then if you are focusing on a water conservation garden, a xeric garden, that's where you get into those low water use. So if you're doing cactus or those kinds of things, those are the low water use plants.
Another tip might be if it's got a woody stem, would that make it a low water use plant, like a lavender or like a rosemary or like a ceanothus?
One that I haven't heard, but definitely makes sense to me.
It would honestly vary per plant. I'll be honest. There are plenty of plants that are very woody that are actually not as xeric as people think they would be. So that's why typically what I'll do is if I know that it's a xeric garden like you're mentioning, Ben, or a specific focus has been put on water conservation for the plant selection specifically, I typically put it in medium just for that reason.
And then
there's a question that's come up, which is there any documentation showing the actual coefficient numbers that WeatherTrack uses? And, you know, I would defer you to a WUCL's crop coefficient list that you can get through a university application, or just type WUCOLS.
Absolutely. So I know that it takes an act of Congress to get that out of us. It's part of the secret sauce, right? What we're using as crop coefficients is something that is protected. So we don't have it in any of our documentation anywhere. But like Ben said, local universities are a great resource for this. Here in Colorado State has provided me exact crop coefficients. I've worked with them for exact turf coefficients. So it's great to if you get down to this level. We do have a feature called custom plants and custom crops where you can actually dial that stuff in if you have it, which is a competitive advantage if you're interested in taking it to that level. If you really want to know what those crop coefficients are, you can ask your local university and then program in what they give you, and the science will reflect exactly what you do.
And that is an option, as you're mentioning there, Ben, too, that at the bottom you see custom plant A, custom plant B, custom turf. Those options are there that if you really want to if you want to nerd it up, then you can nerd it up right there.
Yep, I'll nerd it up with you for sure. All right, let's go to root depth. Here we go. Last but not least, we have root depth. This is the one that I actually manage for frequency questions. If I want to increase or decrease the frequency with which a station is irrigating, root depth is my go-to. Brady?
And this right here, going back to our concept of that glass of water, this is what sets the bottom of that glass. So your root depth sets the bottom of that glass. And that's why this is so important that we get this right. And it can be done pretty simply by, for example, even taking a soil probe in grass areas, for example, using that soil probe, diving it down, pulling it back up, and seeing how far down those roots have gone.
Somewhere my friend Tom Ash is looking down on you and smiling, Brady. That's a trick that I learned from him and has been fail-proof, absolutely. Another way that I would say that is that with WeatherTrack, we're calculating the exact saturation point in that soil. So we know that if you're growing roots down to 4 inches, water at the 5th inch is wasted water. So we are really trying to isolate exactly where we're hydrating to make sure that we're only using the right amount of water. Are you good on this one, Brady?
I'm good.
All right, I'm taking over for this next slide. So because this is the way that I manage, because this is my trick, I created a slide that explains how it works, okay? So with this example, we're gonna have a plant, and your plant is going to have a 4-inch root depth. And with all the other factors combined, that plant is gonna need, across 2 weeks, that plant is gonna get 5 days of irrigation at 10 minutes apiece, right? I made up all of these numbers for simplicity, right? So at 4-inch root depth, in 2 weeks, you'll see 5 irrigation events that last 10 minutes apiece. And across that 2 weeks, you'll get a total irrigation of 50 minutes of irrigation.
If the ET was the same.
What's that?
If the ET was the same.
Right.
Caveat.
So
I want you stepping in another bucket, buddy.
I know, you're looking out for me. So all things being the same, right? The same weather pattern, the same everything, the same exact station. If I go into that station and I change from a 4-inch root depth to a 2-inch root depth, the way that this affects my frequency is when you make that change, the controller knows 2 things. First of all, it knows that when it waters, it doesn't need to water as deeply, right? We don't need to push water down 4 inches anymore. We only need to push water down 2 inches. It also knows that the water from that top 2 inches will be gone significantly faster than it would have been had we pushed it down 4 inches. So when we make that change, we look at the 2-week schedule, and you might see that 10 events, 5 events at 10 minutes apiece turn into 10 events at 5 minutes apiece, right? Greater frequency, but less runtime. But across the board, in that 2 weeks, it's the same amount of irrigation, just delivered differently and optimized differently so that we keep that saturation happening where we need it for those plants. Brady, does that make sense?
Makes perfect sense to me, and I think it's important to highlight exactly what you just said right there. It's the same amount of irrigation, but because we changed that glass from here to here, it waters very differently. And from a perspective of a water manager walking the site, you're going to see it water differently.
Absolutely. This is also a trick that I use in the heat of summer. I get this, starting to get this call. Places where there's water restrictions and you're getting to your maximum allowable depletion, you're getting station high depletion alerts before you can even irrigate, right? Those station high depletion alerts come from as part of the root depth. So if I am getting too frequent station high depletion alerts, I sometimes try and adjust that root depth down an inch or 2 at a time until we can have enough time to catch back up. So that is just one of the many ways that we use root depth in adjusting the programs. All right.
Another way we use root depth too is when you've got newly established plant material. Let's say you put in a new turf panel. It's sitting on top of loam and the contractor's watering it in to pass their guarantee, and so those roots may be an inch or 2. But over time, you don't want those roots just laying there waiting for the hose every 15 minutes, right? You want to train them to kind of find their own way and drive them down. So over time, you might drop that root depth to 3 inches or then to 4 inches. And you can see really healthy turf with roots that are anywhere from 6 to 9 inches deep if you've got well-established turf and the soil that will accommodate that level of penetration. So managing the root depth is also a way of ensuring plant health, not just irrigation frequency.
Absolutely. In fact, one of my super advanced users has trained his root depth for his turf down to 10 inches, where most of our users see their turf at about 4 inches. He just continually did exactly what Ben said. Season after season, he would bump the root depth down 1 inch at a time and continue to saturate underneath the roots, driving them farther and farther down into the soil, and really making that plant healthier and more drought tolerant. It would be able to sustain longer without an irrigation event because of those deep roots.
So not surprisingly, if someone did that and they changed that 4-inch root depth to 5-inch, you'd see a change in frequency, a change in runtime. You know, longer run times to drive water further down, but fewer run times in between because it takes longer for that water to be consumed by the plant or evaporated by the weather.
Exactly it. All right, Brady, great job. You did it. You made it through with flying colors. But now we got to go, Brady, and ask you what I ask all of our guests. What does WeatherTrack save you?
So knowing that this was going to be coming, you know, of course I had a million thoughts go through my head, and I think I can sum it up in one word, and that is bacon.
Nice.
Your bacon.
Because, you know, frankly, bacon should come up in every conversation because it's tasty.
These are your shenanigans, Ben Slick. You asked for this,
Yes.
just so you know.
I asked for it. I got it.
Yeah, you got it. And what I mean by that is we, as Sprinkler Supply Company, we've tried to create a group where we're focusing on water conservation. So WeatherTrack has made it possible for us to have a very powerful tool to help our customers. My response is going to be probably from a different angle, and that is that I'm not in day out changing things and pulling reports. I'm helping customers is what I'm doing. And it's my role to help them understand it. And it's been amazing to watch them see the light bulb go on.
Yeah.
And to see them, wow, this is really working. And so that's one side of it. So you're saving my bacon that way. And also, it is awesome to work with a company and with people that have the same passion that you do. And not only share that passion, but also share friendships and a goal and a drive to save water, which is something that we've greatly appreciated with WeatherTrack and HydroPoint.
So 2 things are true before we finish. 1, you can never get enough Brady. Point 2, we have 2 questions that I want to throw to the panelists quickly before we end here. The first question is there a way to get rid of inadequate number of water day alerts when there are limited water days from the city?
Brady, you want that or you want me?
You take that one, because
the short answer is no. The short answer is WeatherTrack is tracking the science, and the science wants more days, right? It will always abide by whatever water restrictions you have programmed in. So it'll only water when you tell it it's okay to. We don't want to leave you subject to the fines and penalties that can come along with breaking water restrictions. But water day alerts are just a very normal part of the process.
And just know that those alerts, water window alert, water day alert, they auto clear when the depletions get returned to the necessary level.
And your stations will adjust to try and compensate for what it's missing on those days. So we're dynamically changing all of your irrigation to circumvent that. But the water day alert is just telling you that the science wants more days than your water restrictions have allowed.
And we're going to squeeze one more question into this as we get to the end. How does the MAD limit switch affect timing?
Oh man,
that's a whole webinar.
That's a whole episode. The MAD limit switch, leave it in the default setting. It is a specific feature for sports turf in high restriction areas, but we'll get into, there's a whole lot of details. In short, what the MAD limit switch does is in normal irrigation, when we are at a 70% depletion, when WeatherTrack goes to irrigate, it's going to try and water that all the way back to 0% depletion every time it can. With the MAD limit switch enabled, we never apply more than your target MAD at one time. So if you were at a 70% depletion, we would only water 50% back, leaving you at 20% to be made up at a future irrigation program. This
It
prevents
stops extraordinary long run times. It's meant to stop long run times of rotors on turf fields when you've got schedule constantly interrupting for play and maintenance and what have you, that then those long run times will result in which could create damage and, just, plant health problems and whatnot. So it's really meant as a sports turf application.
Yes. So definitely, I get that question a lot, and just leave it in the default and don't play with that. That's one for you want to know you want it before you turn it on. All right. So back to the PowerPoint. We always want to plug the support team and the resources that HydroPoint provides. You've got the 800 number or the support@hydropoint.com, where you can access live support 6 days a week, bilingual help to answer whatever weather track questions you have. We have automated resources online, both at our knowledge base, which has articles, step-by-step articles that for common troubleshooting scenarios, and tech specs and all sorts of resources available at our website if you want just the weather track flyer. And then, of course, what I do is training. We've got great resources at hydropoint.learnupon.com, where we provide certified training, as well as a whole bunch of new material constantly being updated at our YouTube channel. So definitely, if you want more weather track, there's resources for that. And look forward to next week when we'll talk about programming efficiency tools. What that means is big changes, how to change many stations or many programs all at once to save yourself a lot of button clicking and really get into using those big cloud features, those cloud-based features, and leveraging managing many controllers at once. And for that, we'll have Ryan Story, who is our groundskeeper from Vanderbilt University, to provide some insight and tales from the field on those features. So that is all I have for you today. So thank you for being here this week. Enjoyed our time with Brady Pitcher and enjoyed having you. Thanks for being here with us and sharing this time. Mr. Slick?
Brady, thanks. Always good to see you. Thank you for keeping it inside the lines here today for us. We know how you can get if you're left untethered.
I tried.
Thank you. And for everybody out there, have a safe holiday weekend. Enjoy, the celebration of being with family and friends, and be safe.
Brady, you want to take us out?
Thank you all. We'll see you.
All right. Thanks, everyone.
Thanks, guys.